Hello everybody, welcome to Test 1 review in Calculus 2. On the top, you see the topics of the question. And as we go along, I will update that list. The formula will be on that side. Right, let's start it. So first, we will find derivative that involve inverse trigonometric functions. So something like this. The first thing we do is we'll take the function tangent on both sides, because a function will cancel the inverse. So we do that on both sides. And the tangent, not tangent inverse. The inverse, the function cancel the inverse. So we'll have tangent of y equal to 4x over 5. Right. Now we'll take derivative both sides with respect to x. And with respect to x, y is a function of x. So derivative of the left hand side will be secant square of y times y prime, and derivative of 4x over 5 we can write as 4 over 5 x. Either way, derivative of that is 4 over 5. Alright. So we'll take derivative from here to here. We'll take derivative with respect to x. So differentiate. Differentiate with respect to x. And then when we solve for y prime, it is going to be 4 over 5. And then we have the secant square of y at the bottom. Right. We just need to determine what is secant of y and secant of y square. Right. For that, we will look at this. Tangent of y equal to 4x over 5. We can draw a triangle. This is an angle y. Tangent is equal to opposite over adjacent. So opposite is going to be 4x. Adjacent is going to be 5. And the hypotenuse is 4x squared plus 5 squared plus the square root of that. So the hypotenuse will be 4x squared plus 5 squared, or 4x on of the 4x squared. Or we write 16x squared plus 25. Right, so that is the hypotenuse. And then we need secant. Secant is 1 over cosine, and cosine is adjacent over hypotenuse. So hypotenuse over adjacent. Reciprocal of cosine. Hypotenuse is that. And adjacent will be 5. So that is secant. We need the secant square though. We have the square here. So we're going to square both sides. Square of the top will have just 16x squared plus 25. Square cancel the square root. And at the bottom, 5 squared will be 25. And we're going to substitute that in here. We have 4 over 5. Now the secant square, this part is going to be 16x squared plus 25 over 5. Over 25. And 5 and 25 cancel out. We have 5 at the bottom here. Divide by 5 is multiply reciprocal. So we have 4 on the top. Divided by, and then multiply by reciprocal of this. That means multiply by 5 on the top. And the bottom is 16x squared plus 25. So that's why this is 20, which is equal to 20 16x squared plus 25. Alright, so that is that. Right. Now we look at problem number 2. I just draw a line here. Right, for 2. The difference here is we have 3 times the sine inverse. So we cannot take the sine right away. We have to divide by 3 on both sides first. Right? Then we can take the sine function on both sides. Sine and sine. Sine and sine inverse cancel out. So we have sine of y over 3. You can just put the parentheses like this, and then just for x cubed on the other side. Right, and then just like the last problem, we will differentiate with respect to x. So differentiate with respect to x. The left hand side, the derivative of sine is cosine. And then we take the derivative of inside here, which will be 1 over 3 y prime. And equal to the derivative of 4x cubed will be 12x squared. Right? We solve for y prime. So we multiply 3 on that side, on both sides, and divide by cosine of y over 3. So we have y prime equal to 12x square. We need to multiply by 3 on both sides, and we need to divide by cosine of y over 3. Don't get too hung up with the y over 3. That will work out perfectly. Right, so what is cosine of y over 3? Now we are given this. And then we can draw a right triangle. But this time the angle is going to be y over 3. Right. Sine is equal to opposite over hypotenuse. So opposite, we can write this over 1 if we want to. So opposite is 4x cubed. The hypotenuse is 1. In that case, the adjacent will be 1 square minus 4x cubed square, which gives us square root of 1 minus 16x square, x cubed square again, so 3 times 2 will be 6. And then finally, we want cosine. Is going to be adjacent over hypotenuse. Adjacent is that hypotenuse is 1, so pretty much we just have 1 minus square root of 1 minus 16x to the 6th power over 1, or just the square root. Right. And put it back into our problem, we will have 36x squared on the top. The bottom is cosine of y over 3, which is this 1 minus 16x to the 6th. And that's what we have. Pretty much we have to have the trig inverse trig function, and then with a function cancel the inverse. Take derivative both sides with respect to x. Don't forget we have to have the y prime because y is a function of x, and after all we need the derivative. We need the y prime, so it should be there. Right. So that was that. The first topic. Next we'll find the limit using the Hospital rule, and that involving the ln, the natural log. So first, we look at number 3 here. Again, just kind of separate the problems. So first, we'll let y equal to that limit. Next, we will take the ln on both sides, the natural log on both sides. For the natural log, we can just wedge between the limit and that. Right. Properties of the log, when we have ln of something raised to a power, we can take that power down. So the x will go out to that side. So we have ln of y equal to limit of x goes to infinity. Now we will take the x outside. So with that x will go in front of the ln. Now, because later on we will take derivative, so this I will write 1 plus 3 x to the negative 5. Right. Actually, for this problem, the first thing we need to do is put in the limit and see if we have the indeterminate form. That should be the first thing. So put infinity in here, 3 over infinity to the 5th. So that one go to 0. So the whole thing here goes to 1. So this is 1 to infinity indeterminate. Actually, all of this kind of like the lateral move, so it doesn't change anything. So we haven't applied the hospital rule yet, so that's still perfectly fine here. Alright, so in order to use the hospital rule, we need something divided by something. So I will divide the x, try to move the x here down the denominator. Right. Right. Here we have an x to the first power. If we move that down, it becomes x to the negative 1. Right? I'll just say b to the negative 1 is 1 over b. Or precisely, we should say 1 over b to the negative 1 is equal to b. Yeah. When we move to the denominator, or from the denominator to the top, we change the sign of the exponent. Right, here again we can check for the condition. Put infinity here and here, we should have 0 over 0. But again, if the original problem is indeterminate, this will be indeterminate as well. Alright, which means we can use the hospital rule. So if we can check, this is 0 over 0 indeterminate. So I've run out of space there. Right, now we use the hospital rule, which means we will take derivative on the top and derivative at the bottom. Derivative of the top, derivative of ln will be 1 over 1 plus 3x to the negative 5. And then derivative inside will be negative 15 x to negative 4. All of that over x. Derivative of this will be negative x to negative 2. Right. The few things to cancel, the minus and the minus on the top and the bottom cancel out. First we have the limit and one big fraction. Right. First, this fraction will stay the same, so let's just write 1 plus 3x to the negative 5. Negative and negative cancel out. X to negative 4 and x to negative 2 cancel out. So what should we have left? Alright, so I will write that very small here. X to negative 4 over x to the negative 2. When we divide two things, the power of the top minus the power of the bottom, minus 4 minus negative 2. So x to the minus 4 minus 2 minus negative 2 will be x to negative 2. So we have x to the negative 2 on the top, and then just 1 at the bottom, because everything cancel out. Of course, I forgot the 15, did I? So yeah, there's still 15 here, so let's just put 15 on the top there. Right. So we still have the limit. We will have 15 x to the negative 2 and 1 plus 3 x to negative 5. Right. We can put infinity in here, but that kind of confusing. Right, instead, here let's just multiply x squared on the top and x squared at the bottom. Do that just so that we have just the 15 on the top. So we have 15 on the top, and x squared, multiply this out, x squared and 3x to the negative 5. We have 3x negative 3, right? Now we put in infinity in here, so infinity squared is going to be infinity, and 3 infinity to negative 3, that goes to 0. So pretty much we have something like this: a finite number divided by infinity, which goes to 0. So ln of y equal to 0. We still have one last thing. They ask for the limit though. They're asking for y. So we have ln of y is equal to 0 if we raise both sides to the a, take the exponent, raise to the power on both sides, a and ln cancel out, a to 0 power is 1. So after that we have y equal to 1. So the limit equal to 1. So if it is in the 1 to infinity power or 0 to 0 or 0 to infinity, something like that. If it is indeterminate involving the power, we'll take ln on both sides and then try to get the fraction, a ratio of two functions. Then we can use the hospital rule. Okay. And that's what we have. Next week we'll compare the growth rates of two functions. For that, we just take the ratio of two functions and take the limit goes when x goes to infinity. So limit when x goes to infinity of the function, I'll just use for x squared e to the 0.6x. Right. If we put infinity in, we have 4 times infinity square e to infinity power. So of course that will be infinity over infinity. Indeterminate allow us to use the hospital rule. Will be 16. I don't know why I get 15. I mean 8 x over, and derivative of that is 0.6 e to the 0.6x. And if we check this again, 8 times infinity 0.6 e to infinity. So we still have infinity over infinity. So we use the hospital rule one more time. Will be 8, and at the bottom 0.6 square e to 0.6x. We check again, there will be 8 on the top and the bottom 0.6 square e to infinity. So we have 8 over infinity, a finite number divided by infinity, that is 0. Now if it is 0, a fraction that goes to 0, meaning that the bottom will have to go to infinity faster than the top. So e to the 0.6 goes to the infinity faster than for x squared. The bottom goes to infinity faster. This is the bottom. We just say that grows faster. Right, so we got that one. Next we find the areas between the curves. Right, for that we are either given the graph or the functions. So it's going to be either 4 or 5 here. I mean 5 or 6. Right. So for this, we just set up the integral and we can use the calculator. So it will be something like this. So first, this region, we just set up an integral. What we see is on the top is going to be a curve, and a curve given by this function. So the curve is on the top, and the bottom is the line. So we're going to write the integral. We can see it goes from 0 to 4. So the top, negative x cubed plus x squared plus 16x minus the bottom function 4x. And then let's just find this area here. That will be another integral, which goes from negative 3 to 0. But this time, the line is above the curve. Right. We use the calculator to evaluate this integral. We will do a lot of integration. So for here, I just want to, the setting up part is a lot more important. Right, so we bring up the calculator. Right. Alright. So what we have is heat math number 9, and the integration goes from 0 to this 0 to 4, and then the first one we have negative x cubed, just like that, x cubed plus x squared. Make sure we have enough parentheses. X cubed plus x squared plus 16 close parentheses, so that's the first part, minus 4x, and let's close parentheses, and then we have an x, and that gives us, we can convert to fraction. Wait a minute. Why is that negative? Did we? Right. I go back to the integral. Yeah, the curve above the line from 0 to 4. See, we don't. All right, I see. Sorry about that. I don't know why. So we have to enter exactly. That should be 16x. Right. And negative x cubed plus x squared plus 16x. Sorry, I entered it wrong. Minus 4x. Yeah, it should be positive. Convert to fraction. Give us 160 over 3. Sorry about that. And then next, another integral. That goes from negative 3 to 0. A curve. I mean the line above the curve. Negative x cubed plus x squared plus 16x. I forgot the x earlier. Close parentheses here. And that's so 60, it's 75. Math, convert to fraction. So we just need to add these two together. So if we use it, if we can go back like that, we just hit this one plus. When we hit enter, it will copy and paste the numbers, and we will have that. Right. Check the problem again. This look like it. Right. X cubed plus x squared plus 16x. I don't know why I put that negative 4 here. Sorry. 99 over 4. So 160 over 3. 99 over 4. Sorry, just need to put the correct numbers here. So again, that number plus that number plus. Right, 937 over 12. Yeah. Right, sorry, the computer frozen a little. I hope everything is still okay there. Right, put the calculator away. Right, we set up number 6 quickly. We have the function y equal to 2x minus x squared. So if we're gonna solve for 0 equal to 0, 2x minus x squared, then x equal to 0, and x equal to 2. And negative negative x squared, so it open down. So it will be like this. We can use the calculator to check the graph as well. Y equal to 2x minus x squared, and then the other one 2x minus 4. Right, 2x minus 4, when x equal to 0, y equal to negative 4, and when x equal to 1, y equal to negative 2. So we have this line. So we need to extend this here. Look like it will intersect somewhere in here. Right. If we, sorry, that we put the calculator away, and that's what we have. Right. So we have the curve. If we see the graph, it will look like that. Right. Good. And then the intersection. If we need to find the intersection, we just let the two functions equal each other. To x and to x cancel out, x squared equal to 4. So x equal to plus or minus 2. Of course, the intersection will be at negative 2 and at 2. So we're looking for the area here. So the area will be the integral. We see the curve is above the line. The curve is 2x minus x squared, and the line is 2x minus 4, and the limit goes from negative 2 to 2. Right. Put that in the calculator and you should have the answer. Right. So we have that. Right. Next we have this or washer method. Again, for this I'm just going to set up the integral. The calculation of this, we can just use a calculator. Right, first, this method, the formula will be on that side. Right, first, we have to see what we know. The first one, it rotates about the x-axis, which is that axis. And this method, first we need to determine if it is dx or if it is dy. Let me highlight the formulas. I don't know why I cannot highlight C and D. But we need to know if it is dx or dy. So remember, the main thing about this and the washer versus the shell method, this and washer, we will let the increment parallel to the axis of rotation. So we're going to divide a little segment like that will be parallel to the axis of rotation, the x-axis, because that when we do divide this little segment, that little segment parallel to the x-axis. So that is going to be dx. So, and so we choose dx is parallel to the axis of rotation. Axis of rotation, which is the x-axis in this case. So it is going to be dx. I just want to write the formula volume equal to pi r square. It is going to be dx. If it is dx, we see the limit for this region. It is 0 to 2. So the first thing we determine is the limit. Now we just need to know what is the radius of rotation. The radius of rotation is from the axis of rotation to the edge of the region, which will be this function. So will be the curve minus 0. So r is equal to 4 minus x squared. So that will be 0 to 2 pi 4 minus x squared is the radius, and then we square it again because the formula is the radius square. Alright, if we put this in the calculator, leave out the pi and just enter the 4 minus x squared square. On the test, if you use the calculator, just indicate so. Right. Math number 9, 0 to 2, 4 minus x squared, close parentheses, square again, dx. That give us, let's convert to fraction, 256 over 15. So we have pi times 256 over 15, or 256 pi over 15. And in this case, if we use the calculator, just write something like that. Right, next. Find the volume of this region rotating about the y-axis. Now first, we have to choose either dx or dy that is parallel to the axis of rotation. And the axis of rotation is about the y-axis. So we have to stack the increment along the axis of rotation or parallel to the axis of rotation. So in that case, that will be dy. So the volume is going to be pi r squared dy. So first thing, if it is dy, this region, it goes from 0 to 3. That will be the limit. Now the radius, notice that the radius here has to be in terms of y. So when we see the function like this, have to turn that into y, a function of y. So let's square both sides. And then divide by 3 on both sides. So we have x equal to y squared over 3. We just do that first because whatever it is, the function has to be in terms of y. Alright, now we talk about the axis of rotation. It rotates like this. around the y-axis, meaning the radius will be from the axis of rotation to the edge of the region. So which means from 0 to the function here. So the radius in this case from the right is y squared over 3 minus 0 on the left, so just y squared over 3. And then put in the problem, we will have 0 to 3, put the pi outside, and then the r square, r is y squared over 3. So notice when we do the integration, we don't have to write y, any variable will do. So I just say, by the way, if you need a fraction, hit alpha and y and then enter. Convert to fraction, and 27 over 5 pi. So that should not be a problem. Right, moving on. By the way, on this problem, I just make it up so the answer on the back might not be right. So we have the function y equal to e to the x. Y e to the x. So let's just sketch this real quick. When x equal to 0, e to the 0 is 1. When x equal to 1 will be e, and then when 2, e squared. So that function, I just say it look like this. Yeah. That is y equal e to the x. And then x equal to 0. X equal to 0 is the y-axis. And then x equal to 2. And we have this rotate about the x-axis. So we're going to write either dx or dy is parallel to the axis of rotation. Right, axis of rotation is the x-axis, so the increment will be parallel to the axis of rotation. And if we look like that, it's going to be dx. So this is going to be a dx problem. The limit for x in the region is 0 to 2. And then the radius will be just from the axis of rotation to the edge of the region, which is e to the x. So it's going to be r equal to e to the x. Pull out the pi, and then e to the x square dx. I just said 0 to 2 pi r square dx. So we turn to this. Right. Again, just let the calculator do the work and get the answer. In this one, it's going to be a decimal number. It's not going to be anything nice and even. Right. So that is a dish or the washer method. Actually, all of this at disk. We don't have any washer yet. Okay. So we will have a washer later. Right. Next, we'll have a shell method. For that, let's look at 10 and 11 and go to the formula for the shell method. Right, the shell method is this. Let me highlight it, possible. Right. That. So that is a shell method. For the shell method, the first one is that it is rotated about the y-axis. Right. And first this is the y-axis. The rotation of axis rotation is the y-axis. So first we have to find either dx or dy that is perpendicular so the dish and washer method, it is parallel, and this one is perpendicular to the axis of rotation. Right, now this is the axis of rotation, so we have to go perpendicular to it. So if it is like this, we go the other way, increment. So the increment will be in the perpendicular to it, so which means it is dx. So we have the form 2 pi, we have the radius, and we have the height. The thickness or the width is going to be dx. If this is the problem with x, the limit for x here will go from 0 to 3. So at least we have that part. Next, we determine the height and the radius. For that, remember the axis rotations like this. Next, we're going to draw a shell, a cylinder, that is. Let's just pick up like the point like this. That point is going to have the xy coordinate, and we rotate about the axis of rotation. So it looks like that. So this cylinder, the height is going to be this. We see that the height is going to be the function, subtract 0. The function have to be in terms of x. This is the function in terms of x, which is good, and that is the height. And then the width, the radius. The radius is from that point that is the radius. Since the point here is x and y, the radius is going to be x. So put everything in the integral. I will factor out the 2 pi, pull out the 2 pi. The radius is going to be x. The height 3 minus x squared over 9, and then dx. So that's how we set it up, like that. Right. The next problem, the axis of rotation is the x-axis. And then we need to see that if we use dx or dy, so we just leave it blank. Something has to be perpendicular to. with something that is perpendicular to it. So if we stack, it's going to go like this, which is going to be dy. And so we have v equal to 2 pi radius and then the height and times, in this case we say dy. The limit for y will go from 0 to 2. Alright, the height and the radius. Now if it rotates like this, we have to draw the cylinder like this. Right? So this point is just x and y. Right. The radius and the height. The height of the cylinder is going to be this one. Notice that it has to be in terms of y. So let's convert this function in terms of x in terms of y. Square both sides, y square equal to 4 minus x square. Move the x square over and move the y square over. X square is equal to 4 minus y square. And check the square root, because all the x and y are positive. We don't need the plus or minus. Right, so that is the x. And we see the height is from 0 to that x values. So the height will be just 4 minus y square. Under the square root. So that is the height. Now the radius. The radius from the axis of rotation to that point, which is the y values. So we just have just this man from 0 to 2. I mean the 2 pi just left inside. So y times 4 square root of 4 minus y squared dy. Put that in the calculator. Get that. Right. So that was the shell method. Next, we have to do both the dishwasher method and then the shell method. Right, first we have the triangle 0, 0, 2, and 5 and 2. So let's just try to draw it. 0, 0, x equal to 0, y equal to 2, 5, x equal to 5, y equal to 2. So that is the triangle. Right, and it rotates about the axis of rotation of x equal to 5, which is this vertical line here. I would copy that again. Right, we need to do both. So let's say over here we use the shell method, and over here we use this and washer method or washer method. It's either or. Right, the shell method. This is the axis of rotation. We stacked perpendicular to it. So axis rotation here, perpendicular to it. So we have a little increment. Go like that, which is going to be dx. So the shell method is going to be a dx. The shell, the formula is still there. So it's going to be volume equal to 2 pi the radius times the height. This is going to be the dx because we go perpendicular to the axis rotation, and with that it should be the dx. The dx, the limit for x here will be 0 to 5. Now the radius. Now interesting here, then we have to draw. This is the region. Right, axis of rotation. Now we rotate like this. We're going to have a shell inside, and then just get bigger and bigger. So we have a shell. So kind of have a cylinder like this. And this is going to be the radius. And this is going to be the height. We can see that the height is just the line here over this line, diagonal line here. So the height. First let's look at the function. The function here go to 0, 0. So it's going to be y equal to mx. Y equal to mx. And the slope is rise over run, go up 5, and up 2 and 5 units to the right. So y equal to rise over run times x. So the height will be 2, y equal to 2 on the top, and y equal to 2/5 x at the bottom. So the height will be the difference of those two. 2 minus 2 over 5x. That is the height. The radius. And if we have this point, well, we have to start with the point on the graph will be just x and y. So this is going to be x. So this is going to be x. The whole thing is 5. So the radius is going to be 5 minus x will be this part. So we have 0 to 5, 2 pi, radius 5 minus x, the height 2 minus 2 over 5x dx. So that is a shell method. Leave that there. The dish or the washer method. Now if it is the axis of rotation, is this, and we're going to stack either dx or dy parallel to it. If we're going to choose this, it is going to be dy. So it's going to be dy. So washer or this. So either this or washer. It's going to be dy. Right. Now notice since it rotates like this, we're going to have the hollow region of the triangle here, because when we rotate this triangle we have nothing, so there is a hollow. So it's going to be a washer because there is a hollow region. So washer method that involved in the dy. So we're going to have that one. Again, we stacked the increment parallel to the axis of rotation, and that's going to be dy. Yeah, this little segment go along the axis of rotation. Right, for y the limit will be 0 to 2. Right, now the axis of rotation here we go to the edge, so that gives us the little r. If we go to the outer edge, give us the big R. So the big R here is constantly equal to 5. And the little r, we have this line is y equal to 2x, 2x over 5. So x is equal to 5 over 2 y. Remember, this has to be in the function of y. And if we if we have this region, it's going to be 5 minus 5 over 2y, like the difference of two functions. So from this line, which is 5, and then to that line, 5 over 2y. Because it has to be in terms of y. And put that in the formula, we will have 0 to 2 pi 5 square minus 5 minus 5 half y square dy. Right, let's use the calculator and test them both. This one first. I'm just going to leave the 2 pi here. Integral 0 to 5, and we have 2 pi times 5 minus x times 2 minus 2 alpha e y and 2 over 5 x and dx. We have that number 104.7. That's not important. Right. Now we use the other one. Math number 9, 0 to 2. We can either use y or any variable. I just use x. So second, that key for pi. Usually, if we want the exact number, we don't want to leave the pi here, but I just want to leave the pi here because we just compare the two answers. So open parentheses, 5 squared is going to be 25 minus 5 minus 5, that's a fraction over 2x. There. And that's where as you see, we should have the same answer. Yeah. So that was 12. Right. We're going to do this problem in class, so I'm not going to do that now. And there are a few problems of this I want to do in class because that's rather important. I should skip 13 and do that later. Right, arc length. Right, arc length of a curve. The formula will be on that side. Right, on this problem it will be very simple. We don't have to worry about the dx or dy because if it's clearly say from x to this to from this point to that point will be that. Then we have to use x. For this one we have to use y. Sorry, it looks like a typo here because the sine function cannot go to 2. So please change that to y equal to x cubed. I will make that change in class as well. Worry about that later. Alright, so this is going to be, like I said, going to be dx because we have the limits for x. 0 to 5 or 9. Square root of 1 plus derivative with respect to x squared dx. This is the function. Derivative is equal to 3 times 3 over 2 x to the 1/2, which is 9 over 4 x to the 1/2, and we need the derivative square. Is going to be 9 over 4. I don't know why I write 4 there. It would be 2. X to 1/2 square will be 81 over 4 x. That's it. So it will be 0, 5 or 9. Square root of 1 plus 81 over 4 x dx. Right. We use substitution here. I will let u equal to 1 plus 81 over 4x. And then we'll take derivative. And then solve for the x. So the x equal to 4 du over 81. Right. And then we have to change the limit as well. U equal to 1 plus 81 over 4. So when x equal to 0, u equal to 1 plus 81 over 4 times 0, which is 1. When x equal to 5 over 9, u equal to 1 plus 81 over 4 times 5 over 9. Since we have the calculator, we'll just use it. One plus, we have fraction 81 over 4 times 5 over 9. Fraction 5 over 9. Right, 49 over 4. Right. Which means we can substitute everything. X go from 0 to 5 over 9. No calculator here. X go from 0 to 5 over 9 will be 1 to 49 over 4. Square root. That one just u. And dx is 4 over 81 du. Let's just write like that instead. The 4 over 81, we can bring it in front of the integral. 4 over 81, limit go from 1 to 49 over 4. U we write as the 1/2 du. Right. So we have 4 over 81. Integral of this is u to the 3/2 over 3/2. Go from 1 to 49 over 4. Divide by 3/2 is multiply reciprocal. 4 over 81 times 2/3. That gives us 8 over 243. And then u to the 3/2. That goes from 1 to 49 over 4. And then put 49 over 4 and put 1 in, you have 8 over 243. 49 over 4 square, 3/2, minus 8 over 243, 1 to the 3/2. Actually, I entered that in the calculator earlier to save time, which is this one. And we have that, which converts to a fraction of 335 over 243. Alright, next we just need to set up the problem. We do not need to evaluate. By the way, we have to change it to x cubed. Right. So this is going to be y. L equal to the limit 1 plus derivative with respect to y dy. The limit for y goes from 1 to 2. So that's what we have. Y equal to x cubed, meaning x equal to cube root of y. Let's just write y to the 1/3. Derivative 1/3 y to negative 2/3, and then we need that derivative square, which is this one. 1/3 y to the negative 2/3 square. One plus 1/3 y to the negative 2/3 square dy. Right, we just need to set it up. So that's all we have. Right. Next we'll do iteration by parts. 16 to 18. Right, iteration by parts. For this, I'm using the table. Just review real quick. This we need to know this. Which is start with the log and then inverse trig, and then any algebraic expression like x squared, and then the trig function, and then the exponential function. So that is the order that we choose something to be u, something to be differentiate. So we need something to be differentiated. Which is u, and then something to be integrated, which is the dv. Right, so u, we choose, in this case, there's no log, no inverse trig, there's an algebraic expression, so it's going to be x squared if we take derivative, give us 2x, give us 2 and 0. Integration e to the 2x, integral of e to the 2x is 1/2 e to the 2x, or e to the 2x divided by 2, and that gives us 1/2. And then e to the 2x, that is another 1/2, or integrate this is e to the 2x over 2 again, which is 1/2 again, multiplied by 1/2, so this will be 1/4. And divide by 2 again if we integrate, multiply 2 at the bottom, so 1/8. And will be 1/16 e to 2x, and then just keep divide by 2. Right. Integration by parts, we will multiply the diagonals, the sign alternating. After that will be 0. Right. So the integral equal to the first one, x squared times 1/2 e to the 2x plus, that minus 2x times 1/4 e to the 2x plus 2 times 1/8 e to the 2x plus c. Right, rewrite this 1/2 x squared e to the 2x minus also 1/2 x e to the 2x and 1/4 e to the 2x plus c. Right. Next. There's no log, no inverse trig, but there's an x, which is algebraic expression. Derivative of x is 1, derivative of 1 is 0. So all the diagonal after 0 is going to be 0. So we don't need anything after this. Right. Integral cosecant square 4x. Integral cosecant is cotangent, negative cotangent, because the derivative of cotangent is cosecant square. We have the 4 here, we have the 4 here. That's why when we take the integral, we have to divide by 4, so make it 1/4. Same reason here, when we integrate, we have to divide by that constant. Right. What is the integral of e to the cotangent of 4x? I have just find some paper here. Right. Of course, cotangent of something is sine over cosine over sine. Let u equal to sine u sorry, it cannot be u anymore. Let's say v equal to sine u, dv equal to cosine u, du. So du is dv over cosine of u, right? Substitute this back in. Cosine of u over sine u is v now. Dv over cosine of u cancel out. 1 over v dv ln of v plus c ln of sine u plus c. So that is the integral of cotangent of u. If you happen to forget, that's how we derive it. So ln of sine. So ln of sine of 4x. But there's a 4 again. We have to divide by 4. 1 4 times 1 4 is 1 over 16. Diagonals plus minus. So that will be equal to x times negative 1 over 4 cotangent of 4x minus 1 times negative 1 over 16 ln sine of 4x plus c. So negative 1 over 4x cotangent of 4x plus 1 over 16 ln of sine 4x plus c. Right. The next one, we also have a table. We also use the table. We don't have to do it, but we can always use it. Something to differentiate, something to be integrated, and differentiates the u. Right, let's go through the list here. There's no log, no inverse trig, no algebraic expression, but there's a trig function here. So we have cosine of 7x. Derivative is negative 7 sine of 7x, and then derivative again is the cosine of 7x. Then will be another 7, so negative 49 cosine of 7x. Integration, and then because we can keep going, but we will not do that. E to the 5x 1/5 e to the 5x 1 over 25 e to the 5x. The reason we do not go any further than this because if we keep going like this, it will not vanish. All of those problems before we have 0, so the diagonal after that is going to be 0. So we have to make some adjustment. Right. So first diagonal, we still have that. Cosine of 7x times 1/5 e to the 5x and that minus negative 7 sine of 7x 1 over 25 e to the 5x. I should write smaller. Right. Again, if we just keep going like this, it will not go to 0. However, the reason we stop after this step because as you see, when we have cosine and e, after 2 steps we have cosine and e again, and that is very significant. You will see that in a minute. But if we have to stop, it is going to be the horizontal line, still alternating though. but the horizontal line have to have the integral. So plus, minus, and then there's a plus. They have to be in the integral of those two. Okay, negative 49 cosine 7x, and then 1 over, I should write smaller, negative 49 cosine of 7x, 1 over 25 e to the 5x dx. Again, if we have to stop, we have to use the integral. Right, now just rewrite everything here. We're going to keep both sides and write small. Otherwise, we will run out of space. Right, turn this into 1/5. Let's write e to the 5x cosine of 7x. That is positive 7 over 25 e to the 5x sine of 7x. And that actually is negative negative 49 over 25 e to the 5x cosine 7x dx. Notice that we have this term and this term. Those are identical. So what I do is I'm going to move this to the other side. Move this to the other side. So we have e to the 5x cosine 7x dx with plus 49 over 25 e to the 5x cosine 7x dx equal to 1/5 cosine 7, I forgot e to 5x cosine of 7x, I mean that term, plus 7 over 25 e to the 5x sine of 7x. 1 plus 49 over 25 is 74 over 25. Over 25 of that integral. We can just use the I to simplify that, but just keep it like this. 1/5 e to the 5x cosine 7x plus 7 over 25 e to the 5x sine of 7x, and multiply reciprocal of 74 over 25. We have e to the 5x cosine 7x dx over 25 over 74. That. So we have that. Again, the table still works, but notice if we do the table and it not vanish to 0, then we have to stop. When we stop, we draw a line and integrate. right? I think there's one more of this. All right. Number 20. Right, and then we use a table again. We check that list, and it doesn't look like we have anything here. So we have to put the ln of 2x here. And integrate, we don't have anything. So just have to put 1. Right. Derivative of 2x, ln of 2x. Derivative of that is going to be 1 over 2x. Notice there's a 2 in that as well. The chain rule, we have to multiply by 2 by derivative of 2x, which is 2. So that gives us 1 over x. Integral of x of 1 is x. So if we keep going, it will be x squared over 2, and if we keep going, it will be negative x squared. But that doesn't help us. We just keep doing that, and none of that go to 0. So the first diagonal is still there. If we keep doing the diagonal, it will not help us. So we just do the horizontal line, and then we're going to start with the integral. So that will be x times ln of 2x times x minus the integral of 1 over x times x dx. Whatever we have, evaluate from 1 to 3. Right. So x ln of 2x integral, that is easy. Just have that. Go from 1 to 3. X ln of 2x minus x from 1 to 3. Put 3 in here. Minus 1. ln of 2 times 1 minus 1. So 3 ln of 6 minus 3 minus ln of 2 plus 1. So we have 3 ln of 6 minus ln of 2 plus 2. And we're going to leave the answer like this. Except this should be a minus. Minus 3 plus 1, so that's minus. Yeah. Again, we said no calculator, so we just have to leave the answer in that form. Right. We're going to do this problem in class, because this is very important. The most important about integration by parts or substitution is when we need to use integration by parts and when we need to use substitution. So number 19, that's kind of important, and 13, we're going to do that in class. Right, we look at the last page here. There are 3 integration problems, and we'll just go through and see which one, which. So first, when we look at this, if we look at this, it's a product. However, this is not integration by parts, because if we take integration by parts, u is going to be this. It is easy to differentiate. However, this is difficult to integrate. So this will be difficult to do. So we cannot do integration by parts. Besides, here when we let u equal to negative 4x cubed, derivative of x cubed is x squared. So that's some things will cancel with this one. So that one's good. So this one we just use substitution. U equal to negative 4x cubed. And then I'll let you do that problem. The next one. Usually every time we have ln, because if it's not going to be a substitution. I mean, I've said usually, so it's not all the time. So when we have the product with ln like this, that is integration by parts. So this is integration by part. We'll go back and do that using integration by parts. The next one, let's check it real quick. If we use integration by parts, u is negative 7x. And integrate will be sine of x squared. This one is difficult, if not impossible, to integrate. So we cannot use integration by parts. Besides, if we let u equal to x squared, we have derivative of x squared, just x, which cancel with this out, which is good. So this is also another substitution. Let u equal to x squared. Right, I'm going to do 22 and 23. Right, the integration by parts, this one first. Something to be differentiated, something to be integrated. We start with 2x minus 1 for u. Right. If we do that, ln of x, we cannot integrate, so that's not going to work. So switch it up. We have to put ln of 25x here, because when we have the list, the first one on the list is the log, so this one doesn't work. Have to be ln of 25x. Then 2x minus 1. Right, derivative of ln of 25x is 1 over 25x. And then times 25, which is derivative of 25x. So that's just 1 over x. And integral of this will be x squared minus x. Right. If we keep doing that, it's not going to help us. Okay. Quickly, again, this is the list of the thing that we choose to be u, and we have the log. So that's the first thing. So that is u. Sorry, that will not work here. Right, the diagonal positive, and then we will start with the integral sign and negative. So we have ln of 25x times x squared minus x minus integral of 1 over x squared minus x dx. Actually, this is very easy to do. So we just have x squared minus x ln of 25x. This integral distributed, we have just x minus 1 dx. So we have x squared minus x ln of 25x minus x squared over 2 minus x plus c x squared minus x ln of 25x minus x squared over 2 plus x plus c. Right. So that is iteration by parts. So usually when we have a product of log and something else, that is going to be iteration by parts. Unless of course we could get something something like this, in which we let u equal to x cubed plus 1, and then we still use iteration by parts, but the substitution should be first. Right. And bottom line is, when we have the iteration by parts, we should have something that we can integrate. Right. That is iteration by parts on that one. Next, this one is substitution, because we cannot integrate this without an x, you see. Anyway, take derivative. There's no dx here. Move the dx over, divide by 2x, dx equal to du over 2x. And then we will substitute into our problem. Still negative 7x times sine of u, because x squared is u. Dx is du over 2x. Cancel on x, and we have negative 7 over 2. We'll take those outside, negative 7 on the top, the 2 at the bottom, and then we're only left with sine of u du. Derivative of sine is negative cosine. Antiderivative of sine is negative cosine. So 7/2 cosine of u plus c. 7/2 cosine of x squared plus c. Right. As mentioned before, the most important things when we look at the problem, do we have to use substitution? Do we have to use iteration by parts? So make sure we have to use the right one, because this one, iteration by parts, will not work. And that one, iteration by parts. And this one is a substitution. You will do the same way as we do here. I'll let you do that one. So we have 19 and 13. Those two problems rather important, so I want to do those in class. Other than that, we cover all the problem in this review. So you have everything. Alright. So I hope you find this video helpful. Thank you for watching.